Derivation of the equation of motion. So we're going to start from acceleration, acceleration, which is equal to velocity over time, and acceleration equals a equals v over t. That is time. So our a equals our a equals change velocity equals v minus u over t. So therefore our fourth equation of motion is at s cross multiply, that's at equals v minus u. So therefore v equals u plus u plus 80. These are equation one. These are equation one. So I've gotten equation one, now let's go to equation two. So now, using this formula, average velocity equals u plus u plus v over 2. Let's call this equation star. Equation star. So from equation, so um, equation, so from equation one of the linear v equals to u plus 80. We're going to substitute u plus 80 for v in equation star. Substitute u plus 80 for v in equation star. Equation star. So let's bring up our formula, which is v equals to u plus v over 2. So anywhere we see v, we're going to add u plus 80. So average velocity equals u plus u plus, I'm going to add u plus 8. We're going to substitute this v as u plus 8. U plus 80 all over 2. So therefore our v equals to 2u plus 80 all over 2. So our v equals, average velocity equals u, when we divide through by 2, so multiply through by 2, so we're going to multiply through by 2, so u plus our v equals to u plus 1 over 280 recall. Now we're going to recall that velocity velocity equals distance over time. Distance in seconds over time. Distance s over time. Like it's distance s over time t. So velocity equals s t. Let's make s the subject. So s equals v over t. So we're going to substitute our average velocity, what we got for our average velocity, into this equation. So our s equals, we're going to substitute this into this. That is u plus 1 over 2 at over 2. Sorry, velocity v equals d over t. So let's make d the subject. So d equals vt. Vt. So when our d is s, so s equals, our d also the same thing as s vt. So now let's substitute the equation, the answer that we got for the average velocity. We substitute it into this equation. So s equals u plus 1 over 2 at times t times this t. So therefore our s equals u plus 1 over 2 at is equal to square 80 square 80 square. So therefore our, this is our equation 2. So now we're going to, for the last equation, we're going to find the last equation, which is the equation 3. So finding the equation 3 is very simple. So from equation 1, this is our equation 1 up here. Our equation 1 is up here. From equation 1 here, okay, we, which is v equals u plus at, we're going to square both sides. So after, so we're going to square both sides. That is v raised to power 2 equals u plus at raised to power 2. So v raised to power 2 equals, we're going to expand this, which is the same thing as u plus at, those brackets, then times u plus at, those brackets. So I have v raised to power 2 equals u square. When I'm going to multiply, that is u times u, that is u square plus u at u at plus u at again, u at plus a plus a square c square. Expand that, you get 6. Expand it on your own. So v raised power 2 equals u raised power 2 plus 2 uat plus, when you're going to add this together, add this together, 2 uat plus a raised to power 2 t raised to power 2. If you look at this equation closely, I'm going to get something. So v raised to power 2 equals u raised to power 2 plus, factorize these two. Let's factorize this. So that is 2 plus 2a plus 2a all brackets ut. What is common between these two? That is 2a. That is ut plus 1 over 2a t square. So guys, if you look at this formula here, you will see that this is the formula for distance when we got distance for equation 2. That is u plus 1 over 280 square. So instead we're going to substitute this u plus 1 over 280 square as s as the distance. So therefore v raised power 2 equals u raised power 2 plus 2as. So this is our equation 3. Thanks for watching, guys. Don't forget to subscribe to my channel. I remain Osenika. Thanks for watching.